Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at sequences, but we're going to be looking at how to find the explicit formula. So let's go ahead and get started. Now, in the past, when we've looked at sequences, you were always given the formula and then you had to find several terms in order to complete the answer for that particular question, if you will. So to give you an example of this, let's say I have the following sequence. Let's see here. A of n equals n squared. Well, that's simple. So a sub 1 would be the same as 1 squared, which equals 1. A sub 2 would be the same as 2 squared equals 4, etc., etc. But now we're going to be working in the opposite direction. So instead of starting with the actual formula, instead we're going to be starting with these terms. So let me just continue to work this out and show you what's going on here. So a sub 3 is going to be the same as 3 squared equals 9. A sub 4 the same as 4 squared equals 16. And so in other words, I will be left with the sequence like this: 1, 4, 9, and 16. Oh wait, hold on, I got to put in my ellipses. And the question that we're going to be looking at here is that can you go from this right here, can you go from this and get this? That is what we're going to be looking at in this particular video. So with that review, let's go ahead and do our examples here. So our first example is going to be as follows. We're going to have the sequence of 9, negative 81, positive 729, negative 6,561, like so. And then of course we're going to have our ellipses after that, and we're going to close it out like this. So these are the terms that we have, and so we need to try to figure out, okay, so what is the actual explicit formula in this particular situation? Now this is kind of, you have to look for the pattern, and it's kind of intuitive, and so I'm going to try to walk you through how I found the answer, but you know, other people might find the same answer with a different thought process. So the first thing I notice is that my terms are alternating. So positive, negative, positive, negative. This tells me that my answer is going to have some sort of negative 1 to the n. Not quite sure how yet, but it's going to have something along those lines, because this, as we learned in previous episodes, previous videos, is how you get that alternating back and forth. Now, something else that I noticed is that these are all multiples of 9. So 9 times 9 is 81. 81 times 9 is 729. 729 times 9 is 6,500 is negative 6,561. So I just know that I'm going to have something times 9 here. I need to figure that out. Now, here's also what I know. Let's see here. And so if I do 9 to the first power, I'm going to have 9. If I do 9 to the second power, I'm going to have 81. So I'm probably going to have to raise it to a power. And then of course, if I do 9 to the third power, it's going to be that huge number right there, 729. So it's going to be 9 to the n power, but I'm not quite done yet. I still need to figure out how is this going to work the way it is. And right now the answer is no, because negative 1 to the first power is negative 1. And if I take negative 1 times 9 to the first power, I'll get negative 9, not positive 9. So I need to find a way to manipulate my exponent right here so that my first answer is right. And so what I think I need to do is I'll do the following. If I add 1 to this exponent, I should be able to complete it. And so now we can kind of go through this thought process together. And so let's see here. Maybe I should get the calculator out so we can see the whole thing. Okay, so showing you guys the calculator. Let's see if this answer is going to be correct. So negative 1, I'll put that in parentheses. I hope you guys can see this. Negative 1, like so, is going to be raised, and I'll put this in parentheses just to make sure nothing gets messed up. Some calculators can be kind of weird. 1 plus 1 And then we're going to do, I'll put all this in parentheses. This might be overdoing the parentheses, but this calculator has given me problems in the past. Times n 9, excuse me, raise that to the first power. And so you can see I get positive 9 there. You can clearly see that. And so let's do it for the second, for number 2. So let's see here, 2. And then I got put 2 here. You can see I get negative 81. So I know that this one works in terms of how we did it. So let's move to the next one, shall we? Now, let's go to new screen. All right. So our second one, probably not as tricky, but you got to think about it a little bit. It kind of works out as follows. So it's going to be a sequence as the following. Negative 3 over 4. And then we have negative 9 over 8, negative 9/8. Then you have negative 27 over 12, negative 81 over 16. Put a comma in there. Put my ellipses, close it out. All right. Now this one is not too bad. I don't think this takes a lot of intuitive work here. So we go from, now generally what I like to do, and I can't say this is a rule every single time, is I like to take the numerator by itself and see what the pattern is there, and then I like to take the denominator by itself and see what's the pattern there. So when I look at the numerator, first of all, it's always negative. So whatever my answer is, I'm just going to leave that right there in front of it. Now, for my numerator, it goes 3 to 9. So that would be 3 times 3 is 9. 9 times 3 is 27. 27 times 3. You can see this is exponential. 3, we have 3 to the first power, 3 to the second power, 3 to the third power, like that. And so I'm going to call this 3 to the n. That's what it's going to be for the top number. Now for the bottom number, it's not quite like that. It's not moving exponentially. It goes 4, 8, 12. So you could think 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And so you can say for the bottom number, it's 4n. And this one was a little bit clearer, so I don't think I have to confirm it in the calculator. But you can hopefully see the thought process here. So just to make sure that you understand, if I do 3 to the first power, I will get 3. If I do 3 to the second power, I will get 9. If I do 3 to the third power, I will get 27. And for the bottom number, if I do 4 times 1, I will get 4. If I do 4 times 2, I will get 8. If I do 4 times 3, I will get 12. And the negative, we just leave it in front because it's just there. And this right here is our formula. Let's do the next one. This is our last one. Now this one it's actually kind of tricky. So let me show you what it looks like. We got here 1 over e squared. That's the Euler number, if you will. 1 over e, and then we have 1, then we have e, then we have e squared, some ellipses, close it out. Now this one is tricky. And again, to do this one, this is what I did. The first thing I wanted to do was I wanted to convert these fractions so that they're just exponents. And then I worked with that, and then I switched it back to fractions. If I'm losing you, just see if you can follow what I'm doing. So 1 over e squared, another way to write that would be, again, I better put this in a different color. Another way to write that would be e squared, e to the negative square, excuse me. And then 1 over e would be the same as e to the negative 1. And then 1, well, that's e to the 0. Again, I didn't really have to deal with that one. And then e by itself, that's e to the 1. And then e squared is, of course, e squared again. And then I put out my ellipses, and then I'm closing out. Now, when you see it this way, the pattern might be clearer now. Basically, we're starting at negative 2, and we're adding 1 each time. That's kind of what's happening here. You can see negative 2 to negative 1 to 0 to 1. Let me underline this so I'm not talking theoretically here. We start at negative 2, then we go to negative 1, 0, 1, 2, like that. Hopefully, maybe the pattern is clearer now. So now we need to figure out, okay, what do we need to do to start at negative 2? Okay, well, this is what we need to do. We must have an answer as follows. So it would be e, like so, and then we're going to have it n to the minus 3. Because normally we start n at 1. So if I put n in at 1, 1 minus 3 is going to give me my negative 2 here. And so this right here would be the answer for this guy. is not the answer for our original sequence, so we have to convert this back to the original format that we had. And so, you know, the reciprocal of this, if you will, again, I hope I'm not losing anybody, is as follows. It'll be 1 over e, now this time is positive 3 minus n. So this is what you need for the original answer. And so again, you can see this hopefully now. So if you take 3 minus 1, because our first n is going to be 1, so I had to make the chart for you. So if I take 1, and then I have my formula here, 1 e to the 3 minus n, I will get 1 over e to the 2. And then if I put in 2, I would get 1 over e to the negative 1, etc., etc. If I put in 3, I will get 1 over e to the 0, which is the same thing as 1. You know, that's what it is, because anything raised to the 0 power is 1, and so etc., etc. That's how it'll work out. And so you can see that again. You have to look at the pattern, and you have to kind of think about what do you need to do to make this pattern come true. And this last one was kind of tricky, actually, in my opinion. Of course, they could be much worse than this, as we will see in future videos. So let's go ahead and review, talk about what we talked about, if you will, and then conclude this video. So in this video, we talked about how to find the formula for various sequences. And so what you have to do is that you're kind of working in reverse in relation to how we've been taught so far. Normally we start with the terms. We start with the formula, and then we find the terms. But this time we were starting with the terms, and we were finding the formulas. So on this screen, I'm showing you the previous process we've been exposed to, how we would start with the formula and find the terms. And then on the next several slides of the 3 examples that we talked about in this video, we were always looking at how we would start with the terms and then try to work our way backwards to find the formula. And the process for doing this is all about using your ability to identify patterns and whatever knowledge you have about algebra or whatever to be able to complete this. So I hope this video was useful for you and you were able to understand what we were talking about in these semi-complex ideas. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.